Okay, the question is, how do we get the equation from this mechanical mass system? Okay, so now what you do, we're going to solve this according to m. Okay, so according to mass, so we're going to solve it according to the mass. Okay, so what you should know is x2, it's actually connected to this mass. X1, it's actually connected to that mass. Okay, so what you're going to do, you're going to specify, okay, the component in between. So in between m1 and m2 we have f2 and k2. So, and since we know that x2 is actually connected to, it's actually applied to m1, so that's why I'm putting x2 whenever there is a connection to m1. Okay, and for m2 it's x1 that I see there, so I'm going just to put x1. Okay, so in order to solve this, just to make it simple, we're going to solve it based on what we see connected to the mass. Okay, and we do have two mass, so let's start with the first one. It's gonna be this one. You see the way that I'm going to break it down, just to make it easier for you guys to understand what's happening here. So I'm gonna copy this block and then maybe paste it here for now. Okay, now don't forget to add x to those and it was x2. Okay, so this is what you have on the first on m2. Let's go now for m1. You take everything connected to the mass. So everything connected to the mass. 1. So this is what you're going to get. Okay, don't forget to add x. So now we have all the equation, so we'll be able to write now we have separated them, so we'll be able to write the equation. Okay, and for ft, so ft will be equal to, so here we have ft connected to mass, so that we're writing ft equal to m. Okay, and we know that m will be represented as m squared dt function of x1 of t plus, okay, so we're going to end all the things connected to m, so f will be equal to, so it's gonna be ft equal to m plus f2 plus k2. Okay, so we're going to add these 3 and then it will be equal to f. So in short term, so we get this equation, and for f2 it's gonna be d dt x. So instead of writing x1, we can clearly see this is f2, so we got x2 and x1 and f2 in between. So we're going to solve it according to that. So it's gonna be we're going to start with the one close to the mass, okay, close to M2. It's gonna be x1 minus x2, okay, and we're going to do the same for K2. It's gonna be x1 minus x2. It's gonna be plus K2, which is gonna be x1 minus x2. This is what we get as the equation for this first block. Okay, now let's go to this. Let's now solve this one. Okay, and I think I'm gonna need to move this one, so then I'm gonna need some space for me to work this one around. So I'm gonna move this one this side here. Okay, so let's now solve this other one for M1. Let's now solve M1. So what you see for M1, it's gonna be slightly similar to what we just did for M2. So what we know is we don't have FT connected to M1. So meaning instead of writing FT, we will write 0 equal. Okay, we start with M1 d square dt square. It's gonna be x2. Okay, so let me just write it correctly. Okay, this is what you're gonna get for M2. It's gonna be just similar. We're gonna say 0, since we don't have FT. It's gonna be 0 equal to the sum of all the components inside here. Okay, so we start with M, then we're going to write down F2, because what you should know is this one is a function of x2. There's no other force, no other mass connected to those components. Only one mass connected to this component. So which means even this one is gonna be based on x2. Okay, so everything at the top is gonna be, we're going to write down function of x2 times x2. Okay, now what I'm going to write here, it's gonna be f1. Okay, it's gonna be f1 times x2. Okay, now let me go for K1. There's one thing that I forgot. It's gonna be, I need to put this into a derivative dt. Okay, and then plus K1 x2 of t. Okay, we're not done yet. We just write down this one plus this one plus that one. Now let's write down this one. It's gonna be for f2. We're going to have f2, and we're going to present f2 with the first derivative. Now what we're going to write, we're going to start with x2 minus x1, because we're going to put a priority to the one that is inside the mass. It's gonna be x2. This is more the inverse of what we did before. Okay, and k2 is gonna be x2 minus x1. So this is how you get the equation for this question. So you got all the two equations, okay, and you can convert them into S domain and then solve them later on. If you want to write this equation into S domain, you will get something like this. If there's no initial condition, if the initial condition equal to 0, okay, if the initial condition it's equal to 0, what you're gonna get here, it's gonna be in S domain. So I want just to show you when you apply when we convert it into S domain, what we're gonna get. So you get something like this: 0 equal the only thing that you're going to convert into S domain is gonna be this block. It will be that block, this block that you're going to convert into S domain, and this other block. Okay, so you're going to get M1. This is as an example. It's gonna be x squared x f x2 not of t, but in terms of S domain, plus okay, S plus k2 So this is what you're going to get if you have to convert it into S domain. So this is what you're going to get if you have to convert it into S domain for this equation. Slightly different. It's gonna be similar to this one. When you're going to convert it into S domain, it's gonna be just the same principle that you're going to apply here. So this is it about this question, and the goal was to give you explanation how you can get the equation from this mechanical mass system.